Hello, my name is Bengana Jim Jr. and we are part of a group SW-ML-1 where we are presenting self-supervised acoustic representational learning for joint speech recognition and intent classification for low resource African languages. In our group we are two, Bengana Jim Jr., me, and I call Paul, who's currently not available, though he has also been part in the input. He has been contributing to the success of this project. So our group code is SW-ML-1, and our keywords are acoustic representation learning, automatic speech recognition, ASR, intent classification, low resource languages, out of distribution, generalization, and transfer learning. So the idea of our project is that we are trying to build an AI system that can be used by an organization. In this context, we are using COSIS, the College of Computing, and this AI assistant can answer questions in different languages and provide responses in those appropriate respective languages. So this is the content of this presentation. So let's begin with the background. So the project goal of, as mentioned before, of this research was to generate a multilingual AI-powered agent that assists in replying queries about the College of Computing, a very university, in different languages, different Ugandan languages. And so the reason why we found this as an important project to work on is one, over 90% of digital assistants mainly operate in English and French, or mainly these international languages. And COSIS is diverse, provides services to kind of a diverse user base or population. And in certain scenarios, some of these people might not be able to understand English, might not be able to read or write it. So there needs to be a system that is inclusive enough and can be used by people from different backgrounds, in different who understand different languages within Uganda. So how are we approaching this? So we decided to build a translation model, translation system that has the knowledge base of COSIS, what COSIS is, whatever information is part of COSIS, and it can get inputs or questions, queries from users in any language, in a set of Ugandan languages and English, and then can also reply in the respective language. So we are storing our data in a vector database. Basically, we are encoding it, the courses information, we are coding it and storing it in the database. Then we are using RAG, which stands for Retrieval Augmented Generation, to prompt our a fine-tuned large language model. In this case, we're using Phi Mini 4. Basically, what RAG is, it's a method of encoding, querying large language models with a specific encapsulated set of context that you provide to the model, and it answers a question to that specific information. In this case, we're using our courses information, which we have embedded in a vector database. So we're using an LLM as a general knowledge, a general language for general language understanding, because it has been trained on different semantics and structure of how language, since it understands language and can output language well. So that's why we're using the LLM. And of course, our data is for the specific courses related information. Then the output, what we often do is we get an information, get a query in a local language, translate it, to English, query our LLM, then retranslate to the respective language that was prompted. So there are related works that have been carried out, kind of similar to what you're trying to accomplish here. So for example, there is the sunflower mode paper, which is an AI system that was developed by Sunbird AI, trying to approach this concept of LLMs that understand these low resource languages, specifically the Ugandan languages. And for them, they are using Qwen 3 as their base model. Different from us, we're using Phi Mini 4. The main idea was training and fine-tuning a pre-trained model. So the pre-trained model, which is being Qwen 3, to add support for Ugandan languages. They managed to produce a high-quality model, but it's very large in size, requires high compute resources. So we also have another paper, which is multilingual machine language translation with open language models. This uses the GPT model. It is for live language translation. Same, it requires high. It kind of saves on compute, compared to generalized large language models. And we also have another model. This is the NLLB 200, a model by Facebook, and the paper was 200 languages with a single AI model. A breakthrough in high quality machine translation. And the main result out of this is that they really supported a really high number of languages from diverse areas around the world. So if you come to the problem statements, we mainly have the domain problem, which is COSIS has no digital service for local languages. It serves a diverse range of people who might not be proficient in English. And I think it's self-explanatory. And what we aim for this is to generate a model that can answer questions in local language, understand questions, and in the response it replies with context to the COSIS knowledge base. The computation problem we face is a high GPU and compute requirements for these and large model sizes, because generally these large language models kind of encode a huge amount of data, and considering their deep learning models, they tend to require GPUs to run, and we are kind of limited on GPU since they cost really high. And the challenges: limited language data. So majority of these African languages, they are really low resources, as mentioned before. So there is limited data to train our models on. So what are the research objectives? And so the main research objective, as mentioned before, was to generate a COSIS digital assistant that can understand these languages and understand local languages and reply in those local languages context to information about the College of Computing, Makerere University. And research contributions. So mainly what we did, we developed and outsourced we developed our own we mainly had two data sets. We developed our own based off the COSIS information, like the College of Computing. So we mainly scraped the COSIS website and any documents, PDF files that we were able to find around the web that related to the College of Computing, scraped that data and developed a data set that we deployed to Hugging Face under GEM/COSIS Web Info, mainly standing for information about COSIS found on the web. And we also outsourced a data set from Sunbird AI, which is a bit more developed and advanced when it comes to language information, like data about different languages and their respective translations to English. We developed an LLM architecture as mentioned below, including RAG, which integrated some pre-trained models, which is Microsoft Phi 2. And we developed a fully functional UI, which we deployed that a person can access and query. We also have an API, so we have the UI and we have the API, which other developers, an API which has respective API docs, and other developers can also use it to integrate into their systems. So model architecture, we have the web UI, we have the web UI, a backend API, and the model. So the user prompts from the web UI, it goes to the backend API, the model generates the response, and then we return it back to the user. So we have some like the model architecture deep within how the model works. It's a bit of a mixture of transformers and diffusion, where the model is basically trying to calculate, to carry out, to predict what kind of response to generate basing off the prompt provided by the user. So when it came to the model selection and deployment, so we deployed, as you can come down here, we deployed our UI to cmva.open.ug. This is where a person can access our UI and interact with our LLM. We have a simple image of how the user interface looks like, which can sorry about that, which can always be seen in the demo video. So selected models, as I mentioned before, we have a translation model. We are using NLLB, Facebook NLLB, for translating in different languages, let's say from English to Luganda, to Acholi, Runyankole, and all that. Then we have Microsoft Phi Mini 4 as basically the general large language model for language understanding, and as our base model. We are using sentence transformers for encoding. This is basically encoding from our dataset from plain text and turning it into vectors so that we can store it into our vector database. So we're using that. And when it comes to deployment, we have deployed our model to basically our system, which contains the API and the model embedded together. We have them on Google Cloud Run. That's where the API is located. The web UI, we have deployed it on Verso, and we carried out training and fine-tuning and test inferences on Google Colab, which will be in the notebooks. So our datasets, as mentioned before, we have two datasets. We have the generic Sunbird AI dataset. I'm sorry about that. Dataset that contains different language translations, both in English and the respective language. And we have a simple bar graph showing how many samples per languages, and you can see some are a bit lacking, like look bar, which is only just 1,654, and we have others like Acholi, which have close to 5,000. So they have more data to them compared to, let's say, look bar, because these are all low resource languages. And then we also have our own data set that we managed to build. This is the one that is specifically for courses, about courses information. We managed to scrape data on the courses websites and internet, and managed to prepare it. Did some EDA and prepared the feature engineering and prepared the data, published the dataset to Hugging Face, so it's publicly available and can be actually used in other projects. And the Hugging Face repository is Jim Junior. courses web info. Yeah, so what limitations have we faced? So mainly when it comes to courses data, majority of the data is copyrighted, so we are limited on how much data we can actually add to our data sets without incurring legal implications. So that's where we're basically limited to the public data, which is like the website information. If we wanted more data, we'd have to access the administration request for let's say PDF and all that data related to courses. When it comes to compute, the main problem is limited compute resources provided by Cargo, considering we are working with large language models, which are really huge models, and both in size and require a huge compute. When it comes to translation, we also faced a problem where like some languages are really lacking enough translation data that can be used to generate an understandable or a viable translation system. So we tend to limit our system to languages that have enough data to be applied. Those are like things like Acholi and Luganda. When it comes to ethical and privacy, as mentioned before, we have courses data is kind of copyrighted, so it raises an ethical concern or a legal concerns on if we are to apply it and use it to train a model without getting permission from the administration. So when it comes to conclusions, yeah, so this the courses digital assistant is really a much needed system by the College of Computing, because it works with a diverse group of people from different backgrounds, understanding different languages. Some can read, write, others can't. So having something that can communicate with these people in their local languages is like it promotes inclusivity and diversity, which is kind of a good principle to have as an institution. When it comes to the future works, sorry, future works, we aim to support more languages, things like Ateso, Runyankore, Ruchiga, Kifumbira, and more languages that are spoken within Uganda, because Uganda has really a huge amount of language. And we also aim to support voice prompts, because some users most users who really can't communicate English also face a problem whereby they cannot read or write. So you find you cannot be able to read or the response, or even write a prompt to query the model. So yeah, those are our future what we're looking to update to improve this system. Yeah, so when it comes to references, we looked through, like we got references from different works. We have this the first references we have, which are with Hari Krishan. This was conference speech. It was a conference speech in 2025. We found it on ResearchGate. It was large. Language translation using efficient pre-trained NLP models. What we are basically using a pre-trained NLP model. From this year is where we got the concept of using the Facebook NLP 200 model. We also looked at multilingual machine translation with open large language models. The open large language in this case is where we got the idea of using the 5.4 mini, and this is actually a paper by Bengzi, Gao, and Wei Lu, and Juan, and a bunch of other authors. So we also looked at one of our local papers from here in Uganda, which is a paper looking at the sunflower model released last year, which is titled Sunflower, a New Approach to Expanding Coverage of African Language Models in Large African Languages in Large Language Models. So this is an initiative to build a large language model that supports low resource languages, and it was written by Benjamin Akera, John Quinn, Ernest Mwewaze, and a bunch of other authors from Sunbird AI. These models, we have their papers are on the Axiv, I think, axiv.org. And as the team, we are mainly two. We have Pengana Jim Jr., which is me, and my team member Cole Paul. And I also like to give thanks to our supervisor, Dr. Marvin Kaliwango. Thank you. That's it for us, and thank you for tuning in.